Hello, everybody. Thank you for attending today's webinar. Today we're going to be talking about Modbus RTU, remote data acquisition modules, and we're kind of going to divide it up into two parts. In the first part, we're going to be talking about the Modbus RTU protocol, and in the second part, we're going to be talking about individual data acquisition modules that work with Modbus RTU, and then after that, we're going to kind of bring it all together and talk about some application examples using Modbus RTU and our DAQ modules. So thanks again to everybody for coming, for attending. Let's go over our agenda. We're going to start with an introduction. I'm going to assume that everybody who's interested in this webinar is already familiar with Modbus and the concept of data acquisition, so we're not going to do too much background stuff. However, I find a lot of that stuff interesting, and I know I learned a lot just doing the research for this webinar, so we are going to talk about that a little bit. It'll be a good introduction for people who aren't engineers and who aren't so familiar with Modbus. And for those of you who are engineers, it'll be a nice little refresher. Everybody needs a refresher now and then. So then we're going to move into the benefits of Modbus RTU for industrial data acquisition. Self-explanatory there. After that, we're going to move into some of our individual products and product groups. We're going to talk about their features and components. And then we're going to wrap it up with some application examples. We're going to talk about how this works in situ in the factory. So for a little bit of background on us, ICP DAS was established in 1993. Our headquarters is located in Hsinchu, Taiwan. ICP DAS USA, that's us, was launched in 2001 to support the North and South American markets. We have over 200 R&D engineers, and we work closely with them to add new features to our products, develop new products, and to support our customers. Most of our products are RoHS compliant, meaning lead-free, so ISO certified. We're Windows Partner, CE certified, all that good stuff. So let's dive in. What is Modbus RTU? It's a protocol. It's an industrial communications protocol. I can't see my own notes. It's an industrial communications protocol first defined in 1979. Since then, its constituent frame formats have become de facto standards for industrial data exchange. It was originally developed as a proprietary protocol by Modicon, later called Schneider Electric, still called Schneider Electric. Modbus is now an openly published and royalty-free protocol managed by the Modbus organization. If you want to learn a little bit more about them, you can visit modbus.org. They have a ton of documentation available to the public, and they're also a joinable organization. So if you wanted to develop with Modbus, it's a good idea to join the Modbus group. Okay, so the two most popular Modbus protocols are Modbus RTU and Modbus TCP. Today we're going to be talking about RTU. It stands for Remote Terminal Unit, and it is the serial version of Modbus, whereas TCP is the Ethernet version of Modbus. So earlier I talked about the Modbus frame formats. So a Modbus frame consists of an application data unit, or ADU, which then encapsulates the protocol data unit, or PDU. So the ADU is an address plus the PDU, which you can think of as the data, plus an error check. And the PDU is the function code plus data. And we're going to dig into that a little bit more later. So if you don't quite understand what that means, we're going to explain it more. So the most popular protocols are Modbus RTU and Modbus TCP, as I mentioned, but other Modbus protocols include Modbus ASCII, Modbus over TCP, Modbus UDP, and Modbus Plus, to name a few. Modbus Plus, interestingly, is a Schneider Electric proprietary protocol. So things sort of went full circle there, starting out as a Modicon proprietary protocol, and now they're developing their own proprietary protocol again. So I would like to note here that when we're talking about Modbus communication, we're strictly talking about communication between machines and machines, not between sensors and machines. So all communication is digital. And we'll talk a little bit more about sensors and analog data when we dig into more details about the individual products. So Modbus RTU is a serial protocol used with RS-232 and RS-485. It uses a master-slave architecture, which means the Modbus master controller sends commands and receives data from slave devices. It always uses a one master to many slaves configuration. Exceptions are possible. We sell what's called a port sharing device, which allows two Modbus masters to share multiple slaves. But with that, you're going to run into strict limitations on bit rate to avoid signal interference. So like I said, this is machine-to-machine communication, so it's always using binary representation of data for protocol communications. And each command or data signal is followed up with a CRC and a checksum. So the slave units store current data for each channel in both binary and hexadecimal formats. So they have kind of a limited onboard memory that stores the most recent data, including commands. Commands/data are sent at a configurable baud rate. 9600 or 19200 are standards, and from your controller, each slave is assigned an address from 1 to 247. Technically, you can get up to 255, but you run into serious limitations there. Since the master is always addressing the slave, the first byte the master sends is the slave's address. Okay, so what are the benefits of Modbus RTU? Like I said, you can get up to 247 slave modules per master. Technically, it does allow daisy chaining of your slave devices, although at higher numbers, you're going to need to repeat the signal, because you will lose signal strength. Modbus RTU is widely used, almost ubiquitous, and supported by most manufacturers. It's relatively easy to use and develop with. Most importantly, it's an open protocol, no royalties or licensing fees. Uses inexpensive cabling. You can get up to 3,000 feet transmission distance without a repeater using RS-485. And because it's open and free, it easily integrates with SCADA. It's supported by most SCADA systems. So there's a lot of software out there that is developed, a lot of both software and hardware out there that's compatible with Modbus RTU. I wouldn't say that it's the most popular serial protocol, but it is certainly in the top 3. There are, of course, some limitations. For instance, there are hard limits to the speed and size of data packets that you can send and receive over the network. Since I put in this note earlier, it's not 100% true, but Modbus RTU does generally rely on wired infrastructure, although wireless bridges and converters are available. So, Modbus RTU is not a wireless protocol, but there are wireless solutions for a wired Modbus RTU network, if that makes sense. Another limitation to think about is that the market share for all field bus solutions are slowly shrinking in comparison to Ethernet. It's about 50-50 serial to Ethernet right now. And so that might raise some questions as to the long-term, not even the long-term, the long-term viability of Modbus RTU systems. But for most applications, it's still extremely popular. Okay, so now we are going to dig into some products. What we're looking at here is just some examples of our Modbus RTU remote data acquisition modules. And when we're talking about data acquisition, we're talking about collecting data from various sensors, heat, temperature sensors. There's also digital sensors, which are anything that is in on-off format. So yeah, let's just dig in. It's a little comparison table comparing the different RTU products. This one, if you can see my mouse, this one right here, the blue one, second from the left, that is an i7000 module, so you don't need to worry about that one. That's a Decon only. The rest of the Modbus RTU modules are compatible with Decon and Modbus RTU. So here on the left, we have the TM series, which is some of our most popular configurations in a small form factor. And then this is going to be our M7000. The third from the left, the gray module, is going to be the M7000 series. Directly to the right of that is the M2000 series. To the right of that is the M6000. So here we just have a brief overview of the data formats they accept. Maximum number of nodes. See, 256 is the technical limit. They all have a dual watchdog, and importantly, you have the max channels, and this is the max channels for the whole series, not individual units. So for most of them, the max number of channels is 16, and then we do have the M6000 series, which is a big old data brick, and that has up to 32 channels. Okay. So let's talk about the M7000 series. This includes some of our most popular, not only some of our most popular Modbus RTU modules, but some of our most popular products overall. It accepts analog input types, current voltage, thermistor, thermocouple, frequency, relay, strain gauge, etc. The whole gamut there. It comes with Decon Utility, an easy data logger software. Decon Utility, kind of confusingly, is what you will use to configure the module, even if you're using it with on a Modbus system. And Easy Data Logger is our data logger and SCADA software, and we're going to talk a little bit more about that at the end. But every module we sell comes with the software you need to set it up and run it. And yeah. Okay, so this is the M7002 module. This is a 4 analog input, 5 digital in, and 4 digital out. It accepts voltage and current input. It's got 5-channel sync source, wet contact input counter on those digital channels, on those digital in channels. For digital out, it's got 4 Form A relay outputs. It includes photocouple isolation. Communicates over RS-45 using Modbus, and at a configurable baud rate of 1200 to, what is that, 115,200 bits per second. So, like I said before, you can configure it with Decon Utility and control it using Easy Data Logger. This is one of our more special and interesting modules because it is a data logging module. So it's 16-channel current input, it's analog input. And unlike the rest of the modules we're talking about here, it logs data on board. The idea is to save time and effort when measuring current input with its built-in resistors, allowing you to measure current directly on this device without needing to add an external resistor. It has a fast and normal adjustable sample rate of 10 and 200 hertz. And onboard storage for 100,000 records from 16 channels. So when we're talking about our remote data acquisition modules, what they do is they take analog or digital signals and they put them into a machine-readable format that you can then transmit to the controller. And then with SCADA, you can display and you can display and log the data in a human-readable format. What the data logging module does is it logs data directly on board, and when the master queries it, the calculations are already done, and you just need to display the data. Okay, moving on to the TM series, like I mentioned, is some of our more popular configurations in a reduced form factor. It brings the advantage of a smaller size at a reduced cost, at a few trade-offs, fewer I/O configurations, fewer features, and fewer total number of I/Os. Also, as you saw before, max number of nodes is capped at 32. This version is DIN mountable. Okay, so this is the TM-AD5, an example of one of our TM modules. It's a 5-channel isolated voltage input, the programmable input range that you see there. It also has an adjustable sample rate, 4 kilovolt ESD and EFT protection, and 3 kilovolt surge protection. So there are a lot of, especially in our M7000 series, there are a lot of different I/O configurations and a ton of different modules, so I'm just giving you one example of each. And at the end, we can refer you to selection tables to give you a better idea of the scope of the products we're offering. Now we're moving on to the M6000 series, which is a series of just 2 products, a 16 and a 32 channel universal I/O module using, again, RS-45 and Modbus RTU. The advantage of this is that it's lots of I/Os in one place. The disadvantage is that it requires the user to configure universal I/O channels according to their specific requirements, and this one is screw mounted. The M2000 series is just a couple of modules. They come in 4, 8, or 16 analog input only versions. These are the low-profile DIN mounted cases. The M2004 is the 4-channel option works specifically with DS18B20 temperature sensors. The 2017, the 8-channel version, uses configurable analog input. The M2018-16, the 16-channel version, supports current voltage or thermocouple input. So as you go up, you get more input channels and more options for sensor input. Okay, so now that we have an overview of what our data acquisition modules look like and what they do, and you know some of the features, we can talk about how they work in a Modbus RTU system. So the master-slave architecture means that the DAQ modules don't offer information to the controller. The master requests data from the slave, which sends data back. The slave modules take samples from the connected sensors at a pre-configured rate and store sensor data on board in coils, coils being the digital binary format, and holding registers, which are the analog which are a hexadecimal format storing analog sensor data. The way this works is the master makes a request. The request always starts with the slave's numeric address, or 0, which is broadcast addressing all slaves, before it sends the command. Right. Slaves respond back to the master with their respective addresses so that the master always knows which unit is responding and the requested data. So if the master sends out a request for the most recent digital data, it'll send that back along with its address, so that information can then be logged into the system on the master and accessed there. In theory, an operator could manually send commands to each slave module, up to 247, and then manually receive and interpret data. That, of course, would be madness. So it's better to incorporate Modbus RTU devices into SCADA, a system that sends requests and interprets data into a human-readable format. And so we're going to talk a little bit about Easy Data Logger. Easy Data Logger is our proprietary SCADA software. You get a free version that comes with any module you buy. Easy Data Logger is our data logging and SCADA software. Provides a graphic interface and software control center for your Modbus RTU data acquisition system. It comes with a number of features. It enables module search, database connection to database. That's your data logs. Control logic using VB script. So that is just basic logic control functions. You can also send email or text alarms, and it allows you to create virtual channels and tag units. It also supports Decon, Modbus RTU, Modbus ASCII, Modbus TCP protocols. So basically, Easy Data Logger, the free version, enables the creation of a small-scale data logging and SCADA system. It comes free with the purchase of any ICP DAS module. It enables users to quickly and easily build a data logger system without programming knowledge. It can be applied to a small remote I/O system using our DAQ products. Basically, the most important thing is that it provides a control center and a GUI. It allows you to read and interpret data, to manipulate it, to store it, to send it up to other places. Also, it allows you to send custom commands or to set up logic controls based on sensor data. So in conclusion, Modbus RTU is one of the most popular serial protocols available. It's openly published, royalty-free, and compatible with a huge array of software, controllers, and modules. RTU balances cost and performance with a speed and bandwidth suitable to most industrial applications. But if you do need a super high transfer or sample rate, we do have high-speed Ethernet data loggers that we data acquisition modules we actually talked about in last month's webinar. So if you're looking for something like that, I can refer you to the video from last month's webinar, because I think would be very helpful. Finally, Modbus RTU is easy to use, it's easy to develop for, and it's nearly ubiquitous. It's hard to go wrong with Modbus RTU. Okay, that's it. If you have any questions, please ask them now. I have some people here from tech to help me, to help you out with any more technical questions that you might have. Please, if you think of any questions later, please make note of our contact information. You can always call us on the telephone on our toll-free or our direct office number. Our website is icp-usa.com. Always, you can send us an email at sales@icp-usa.com. And please, please, please follow us on LinkedIn, Facebook, and Twitter. We do post regularly. We try to make it interesting, fun, and informative. So, give us a like, give us a follow, smash that like button. You know what to do. Do we have any questions?
Okay, let's see. First question I see, what is the typical voltage between the A and B terminals of the Modbus connection? Let's see, not sure. I believe you just mean the RS-45 terminals. For the RS-45 terminal, it's typically 5 volts plus or minus. Usually you see fluctuation between 0 and 5 volts, but since it's moving so fast, you'll roughly see 5 volts for most of our devices typically. Let's see. If you do mean DC voltage to power the module, it's typically 10 to 30 volts DC. The next question, see these, they appear so tiny over here. Is there a way to determine the best bit rate and baud rate to use given the RS-45 Modbus communication. Typically, the faster you communicate, the shorter the overall distance. If it's a very short bus, I recommend 115-200, but 9600 is typically used for most standard applications. The farther you're transmitting, though, the slower the baud rate limitation. If you do, want to get as fast a communication as possible, of course, faster baud rates are better. So probably start with the faster baud rates, maybe 19.2 or 115-200, and if that doesn't work, then you can go down to like 9600 or even lower than that if necessary.
Ooh, I would just like to point out that question asker Paul Chidley has pointed out that I was wrong in answering about registers and coils. Coils are 1-bit registers, and the registers are 16-bit.
Yeah, let's see. Coils are used for digital output statuses, typically on or off, or actually always on or off. So it'd be 1 represented by on, 0 represented as off. For the holding register and analog input registers, they're a 16-bit. For floating numbers, you can combine two 16-bit registers into a 32-bit number and get or use Modbus communication to get the value in float. But typically, they're 16-bit numbers, and holding registers are read-writable, so for analog output, whereas input registers are read-only for analog input. So, like for instance, a thermocouple would give a value where you can't, manipulate it. But if you want to say set a set point for a temperature, then you use a holding register, which you can manually override or change. Let's see, what electrical and environment such as CUL is available? Let's see, typically our devices are CE only. If you do require special approvals, we can do it on or per module basis, but typically there's an NRE fee associated with that if it's required. But please contact the sales department and talk over any electrical requirements, specifics that you need. Perhaps we have a module which may have already been certified for some reason. Let's see, that's already been answered about the difference between coil and holding registers. Let's see, are there any modules which are Class 1 Division 2 certified? Typically, no. Our modules are traditionally put into, what? Oh, okay. Typically, our modules are put into enclosures for these type situations. If, you do require Class 1 Division 2, that's what I'd suggest. We don't have any modules which are explosion-proof at the moment or can be used in Class 1 Division 2 environments. Let's see the components. Okay, this has been answered. We are CE only. We don't have UL. Let's see. Are your Modbus ports isolated? Is this communication port or is this module or I/O channels? For the I/O channels, typically they're, well, we have some modules which have isolation, but traditionally no. Most of our analog inputs go through a multiplexer, so there is some noise leakage. If you do require isolation, we do have some analog inputs which are differential. They still go through the multiplexer, but since they are pulled individually, the isolation is usually minimized by electrical circuits, but we can talk to you about specific needs if you want. Let's see, okay. Can the DL and CL data logger modules be added to the Easy Data Logger software without any ICP modules? You do need RS-485 communication. Let's see, for the CL and DL. Let's see, actually we do have some Ethernet modules as well. They can be used with the Easy Data Logger. I believe they're listed as data acquisition modules. I will check that and we'll get back to you on that to verify. I need to see the requirements. For sure, the I7000, M7000, and TM modules all of them can be used with Easy Data Logger with standard limitations. Let's see, that was it. What is ecom? I don't understand. Let's see. I believe it's concerning, will Decon work on a PLC or just a PC? Decon Utility is the software for for configuring the module that runs on a Windows PC. Let's see, if you mean communicate to a module with Decon protocol, some PLCs will accept ASCII-based commands and responses. This would be used with, like, for instance, Indusoft has a TX RX driver where you send a serial string and get a serial response, and you have to break down the response into meaningful results. So you can use it if the PLC does have that ability. Let's see. Okay, do you have a free simulation software for practice purposes? Let's see. Not sure what you want for Modbus RTU. There are Modbus slave simulators out there. We don't provide one. We do have a Modbus master simulation tool to communicate and test our modules with, or you can use some standard software like ModPol or ModScan. Let's see. Okay, that's all the questions I see right now. Does anyone have any last-minute questions? Oh, here's one more, actually. Let's see, Easy Data Logger doesn't support CL and DL. If you do have at least one data acquisition modules like the TET A4, you can use third-party or the CLDL modules with Easy Data Logger for up to 32 I/O channels for the free version. The TET would meet the requirement for at least one of our data acquisition modules. Okay, I don't see any other questions, but if you do have any, please feel free to contact us at the numbers or emails shown here, and please link to us on LinkedIn, Facebook, or Twitter.
Okay, everybody. Thank you for your questions. Thank you for your attendance. I hope everybody has a great Friday.